This question is about structure and bonding. Draw a diagram to show the strongest type of interaction between two molecules of ethanol. And then we can know immediately that because ethanol has an alcohol group, the strongest intermolecular force is going to be hydrogen bonding. So there are sort of three main things to think about in hydrogen bonding. Hydrogen bonding is an attraction between a delta plus H and a lone pair on an NO or F in a neighbouring molecule. So in this compound, it's an oxygen, not an N or an F, and therefore we're going to from a lone pair on an oxygen in one compound to a delta plus H in another, and that hydrogen bond is in a straight line with the original OH bond. So the C2H5 is irrelevant, really. That's just an R group. If you know your hydrogen bonding diagram for water, you could almost draw it as water and then rub out one of the H's and replace it for a C2H5. I'm going to draw my lone pairs in orbitals just to make them stand out. And then I'm going to put on my delta plus hydrogen, which is delta plus because oxygen is delta minus because it's more electronegative. And so that I get the straight line part, I'm going to draw my hydrogen bond now in a straight line from my OH bond. So I'm actually not going to draw my second molecule until I've drawn my hydrogen bond. And remembering that my hydrogen bond goes to a lone pair, so I'm going to draw my lone pair, then I'm going to put my other oxygen, has a second lone pair, and off there is coming a C2H5 and a hydrogen. It's delta plus and delta minus, and I will have scored all the marks. I've put on the dipoles, I've put on the lone pairs, and I've put on the hydrogen bond in a straight line to an OH. Methoxymethane is an isomer of ethanol, so it has all the same atoms, same size, same MR, same strength of van der Waals, but doesn't have an OH group. And notice now its boiling point is much, much lower than that of ethanols. Why is the boiling point different? So between ethanol molecules, there are hydrogen bonds. Whereas remember this is between the molecules, not in the molecule, between methoxymethane molecules, there are only permanent dipole-dipole forces. Hydrogen bonding is stronger than permanent dipole-dipole, and therefore more energy is needed to boil ethanol, the one with the hydrogen bonding. Draw the shape of the POCl3 molecule and the shape of the ClF4- ion. Include any lone pairs of electrons that influence shapes. In the POCl3 molecule, the oxygen atom is attached to the phosphorus by a double bond that uses 2 electrons from the phosphorus. Name each shape and suggest the value of the bond angle in ClF4-. Now, because it doesn't have double bonds, I'm going to do the ClF4- first. So chlorine is in group 7, so brings 7 electrons to the valence shell. Each fluorine bonds to the chlorine, bringing 1 electron. So that's an extra 4. And a minus charge is an extra electron. So if we add this up in total, we've got 12 electrons or 6 pairs. 6 pairs of electrons around the chlorine, but only 4 bond pairs. So we would have a lone pair at the top and a lone pair at the bottom. Would have been octahedral, but 2 of the bonds have become lone pairs. And so the shape is square planar and the angle is 90 degrees. Now if we consider the POCl3, it's a little bit trickier because the phosphorus is in group 5. It's using 2 electrons to make a double bond to oxygen and 3 electrons to make 3 separate single bonds to each chlorine. So it's a bit harder than, you can't really add it up in the same way. So you could sort of almost subtract. I'm using 2 electrons for the double bond and then 1 for each of the chlorines. So there are no lone pairs. So there are 5 bond pairs, but no lone pairs. But there are actually only 4 bond areas because one of them is a double bond. And if there's 4 bonds and no lone pairs, then what we need is tetrahedral. And so we want to draw a tetrahedral shape with a double bond and 3 single bonds. Tetrahedral. It may be that you have to draw a dot and cross diagram to visualise that. So using your GCSE knowledge, phosphorus in group 5, so it has 5 electrons. It uses 1 to bond to each chlorine. I'm not going to draw all the rest of chlorine, 7 electrons. And then it uses 2 to make a bond to the oxygen, because remember oxygen only has 6. And so we can see that it's got 4 atoms around it, no lone pairs, and 4 bond areas.